Let's look at this challenge question here from 12.5. So we want to find the equation of the line of intersection between two planes. So we have these two planes here. I've drawn them as this purple plane and this pink plane. And I'm trying to find that line of intersection, that green line of intersection between those two planes. So we need to figure out how we can do that. Because I want the equation of a line, so let's put this down. I want the equation of a line. So I should be trying to find a point on that line and then the direction vector of that line. So let's think about the direction vector first. The direction of this line is in the direction of that is contained in that purple plane, but that direction vector is also contained in that pink plane. So this direction vector is in the purple plane, and it is in that pink plane. Since it's in that purple plane, it must be orthogonal to the normal vector to that purple plane. So it's orthogonal to that normal vector, n2. And since it's in the pink plane, it's orthogonal to the normal vector of that pink plane, which I've called n1. So the direction vector of this line is orthogonal to both n1 and n2. Therefore, if we take n1 cross n2, take the cross product of those two normal vectors, I get that vector, which is orthogonal to both of them. That will give me the direction vector of the line. So let's go ahead and do that. So let's call this guy our purple plane. We'll call this one our pink one. So I'm going to take those normal vectors by just looking at the coefficients. So I get 1, 1, negative 1. And here I get 1, negative 3, 4. I'm going to take the cross product of those two normal vectors. So I get I, j, k, 1, 1, negative 1, then 1, negative 3, 4. If I take that cross product, I get the I component is 4 minus negative 3 times negative 1 is just 3. The j is always negative, so that's going to be 4 minus negative 1. And then the k is negative 3 minus 1. So I get the normal vector 1, negative 5, negative 4. Okay, so I found the direction vector of my line, right? The vector which is normal to both these other two vectors, so orthogonal to both those vectors, is the direction vector of that line. So this is my direction vector. Now I want to find a point on that line. So how do we go about finding a point on the line? Well, that point is in both planes. Okay, so I have to find some point that satisfies both those planes. So it both has to satisfy x plus y minus z equals 1, and x minus 3y plus 4z equals 1. We know there's infinitely many points that satisfy this because I get an entire line. So I can try to just set up and solve, maybe like solving a system of equations. So from the first equation, I can solve for x. So x is equal to 1 minus y plus z. I plug that in for the x in my second equation. 1 minus y plus z is equal to negative 3y plus 4z equals 1. Oops, I don't know why I said equals 1 there. Let me fix this. 1 minus y plus z, that was my x, minus 3y plus 4z. So x minus 3y plus 4z equals 1. So if I combine terms here, I get 1 minus 4y plus 5z is 1. So the 1's can cancel, and I get that 4y equals 5z. So now I can actually pick a value for either y or z, and that'll help me find everything else. So let's pick, say, I'm going to let z equal 4, because then I get 4y equals 20, so y equals 5. I get nice integers there. If z is 4 and y is 5, x was just 1 minus y plus z, so therefore my x is equal to 0. So that's a single point on this line. So I get the point 0, 5, 4. So then my line can be written as x of t equals that point 0, 5, 4 plus t times that direction vector, 1, negative 5, negative 4. But as we're doing this, right, maybe we say, okay, what if I hadn't even found this normal vector? Can I just go through and solve these two expressions, right, solve for things here and get a solution? So what did we find so far? We saw that x was equal to 1 minus y plus z, that 4y was equal to 5z. So now I could also just let one of these be my parameter. So I could say maybe let x, well, let's say let z, because that one's kind of easy to solve for here, equal t. Then 4y equals 5 times t. So y equals 5/4 t. And then x is equal to 1 minus y, so minus 5/4 t plus z, which is t. So that's just 1 minus 1/4 t. So I can also say that x is my x vector. The x was 1 minus 1/4 t. The y was 5/4 t. And then the z was just t. So that's another way to write that line. If I have the equation of a line, I can always write it like this, or I can sort of think about reparameterizing that and sort of changing that value of t. So I could do something like plug in 4t for t instead, and then adjust to make sure we have that line that doesn't have any integers. But you can, any fractions. It's only integers. But we can write it like this as well. And that's just another way of writing the same line, where we didn't have to do the normal vector. So either of those ways is fine.